Hello everyone, and welcome to a quick coding with lying video as I give an update on what is going on with the project. So, this is the latest build of what I've been working on, and I am pleased to announce, as you can see from the left hand side there, that the neural network is in fact now running. So, you can see that if I shove this pig near him, he does not react in the slightest way, which is good because the pig is evil. And if I stand near him, the network also has no meaningful response, but if I drop a zombie, off he goes. Perfect. Now he only does this with zombies, and as you can see from the output, I just scroll it up a little bit. There we are. Starting new network run, and then this is the output of each individual neuron in turn. So the first 3 neurons are in the same layer. They're taking direct response from the input values that the network is getting. And the 4th neuron is the output neuron, which is determining this neuron is on, these 2 neurons are off, I should output. Meaning, yes, this is a good time to run. Now, in the case of these first 2 neurons, they're just looking for the entity ID that matches a zombie, which is to say the number 54. And then the third one is looking for a zombie in close proximity. So ultimately that means that if a zombie is within a certain range, and the zombies presently do not target neuro-villagers, but they might do in later versions, just for testing in algorithms and such, then the neuro-villager will determine to flee. This is basically replicating the same behavior that a standard villager experiences. Now, I have had to go a little bit into the interesting stuff here. So this is the current look of the neural network system. I do have a few different print lines just hanging around for testing while I was sorting out a few bugs, but this is where it outputs the different neurons. Everything goes through quite as it should. We've got our booleans going through there nicely, and then we get to this section, which is sort of an artifact of the original entity AI avoid entity, where we have this section, which is currently being effectively handled by our neural networks. This is should I run? Effectively, it's looking for, is this an entity? Well, is this a player? And then all different stuff. And then where is the nearest entity that I'm actually looking for? The actual by class stuff, which we can't really reasonably do with the network. The network works best if it's handling numbers rather than characters and names and such. And then here we have the practical considerations. Can I run? So it's picking a random position, and then it's determining if that position exists, if that position is closer than the entity we're trying to flee, which is to say if we're not going to make a meaningful run, and then it's actually running the actual thing. So basically it's working by exclusion. If I've made it this far, then I can actually return true and start running. Whereas this is more of a conditional. It's always going to check this stuff, and then it's, if I've made it this far and the input from the neural network has come out true, just say is it 1.f or float, then run. So the logical conditions are being handled entirely by the network, which means they are subject to change once the learning algorithm is installed. And the practical conditions of can I run, can I eat this, can I farm stuff, that kind of thing, are still handled by booleans because they're more to do with just interaction with the world. That's direct interaction rather than consideration. And the consideration is where things get intelligence in this system. So that is what's happening right now. My next thing that I need to do is to actually install the learning algorithm, which is going to be probably back propagation, and I'll talk more about that in the next video. But right now, this system is successfully replicating the outputs of a Boolean standard system, which is what this was previously using. It's, of course, using up quite a lot more resources, and it's a lot more wordy in terms of programming code to achieve this. So currently, it is a flawed system, and it is just more work to get the same output. The learning algorithm will change this by allowing the original coding, so these, let me see if I can, there we are, these neural network weights to change over time, allowing behavior to be more fluid and variable, which is something that the booleans cannot handle very well. So with that in mind, I hope you've enjoyed this quick look, and I shall catch you all next time.